Okay, well, we are going to see if we can make this work today. I know we're going to kind of go out of order here, but what you're going to see here is I think you're ready to handle Kinetics Notes number 4. I know we've only gone through Kinetics Notes number 1, but we're going to be able to, I think, make the jump and be in good shape. This is all about half-life. And that's really defined as, and many of you I know have already had this in like a math class, so that's terrific. But as you see here, it's the time needed for a sample to decompose. Okay, and that time, as it says here, remains constant. It remains constant. And so I remember when I was first learning this, thinking, oh, okay, so if it takes a certain amount of time for half of the sample to go away, we're going to say 5 years, this sample, half of it goes away in 5 years as it decomposes, well then, gee, in another 5 years, the other half will go away. Well, that's not the case. What happens is this: 5 years for the green part, half of the remaining sample, this also takes 5 years. And then we say, well, gosh, that took 5 years, half of the remaining took 5 years. So now we're at 15 years, okay, total time, and then another 5 years goes by, and it just keeps cutting half over and over and over. So it's like a 5-year cycle in this example. It's always 5 years, and it always cuts the sample in half, okay? That's a big deal today. And I don't think it's very difficult. In fact, it's not going to take me long to show you what we're talking about. In the next example here, I'm going to say, because I think you don't really need very many examples, in this one, I'm going to say the time interval for a half-life, in the cool way of writing that is t 1/2. And I'm going to say it's 10 minutes. Okay, 10 minutes for a half-life for a given sample. In the first 10 minutes, we see that 50% reacts. 50% reacts and goes away, breaks down. In the next 10 minutes, we would then see this amount go away. So it's been a total of 20 minutes, and what we saw here was that of the original sample that I'm shading in red is actually 25% of the overall sample. You see it's a quadrant, lower left quadrant. So after a total of 20 minutes, 50 plus 25, you can see that 75% of my original sample has gone away. 75%. There's only 25% remaining. Well, let's continue. And again, I think you see the pattern. Another 10 minutes pass, and that's going to take this amount away. Again, half of what's left over. So that would be 12.5% has reacted in that 10-minute time. So after 30 minutes, 10 plus 10 plus 10, we see that we have gotten a total of 87.5% has reacted and gone away. We're left with only 12.5%. So there are two ways that we can say how much has reacted versus how much remains. Okay, how much has gone away versus how much is still left over. So if we continue on, and again, I think you really only need one example and then some practice here. Another 10 minutes goes, and we'll cut that in half. And so we see, hey, how much of that is reacted? 6.25%. Then again, another half-life comes along. We cut it in half again. That took 10 minutes. It's a constant 10-minute cycle. And now 3.125% has reacted. And we could continue on and on and on and on. So after 5 half-lives, we see that all of this, we could add all those numbers up and we could see how much has reacted, or we could say, well, that's how much is reacted, how much is still left over. If we look downward, and again, I think many of you are probably have already seen this in the past. Here are 2 practice problems, and then we'll get you going on some other stuff. The half-life of iodine 131 is 8 days. That's an important thing. It's 8 days. So what I'm able to say there is T1/2, a cycle is 8 days. If a hospital receives a shipment of 200 grams, how much iodine will remain after 24 days? So I would say, well, how many cycles will I go through? And what I see is if T1/2 is 8 days, then I know I'm going to have 3 half-lives. And I'm sorry, my handwriting's not so good this morning. So what we're going to say is, hey, I started with 200 grams, and as I cut this box in half, after the first half-life, I have lost 100, so now I'm down to 100. After the second half-life, I've now lost another 50, so I have 50 remaining. And then after the third half-life, I've lost 25, and that leaves me with 25 grams left over. Final answer there. Okay, so it's just how many half-lives are we talking about? In the last one here, we see that what we're saying here is the half-life is 3 days. How many grams of mercury 197 will remain after 12 days? 12 divided by 3 tells me I need 4 half-lives. 4 of the half-lives. So it's going to go through 4 cycles. So again, how I would recommend doing it, 32 after 3 days, a half-life, I'm now down to 16. After another 3 days, I'm down to 8. After another 3 days, I'm down to 4. And after another 3 days, I'm down to 2 grams. So 2 grams remain. Okay? It really is that simple. Now what I'd like for you to do is go right into the worksheet that has some multiple choice questions dealing with half-life, and if you can do those, you're in great shape. Again, a pretty easy concept, different ways to go about it, and I think this will work for us. Thanks for watching. Have a great day.